Okay, so in the next couple of videos, let's review again some of the concepts that we have learned, like the kinds of data and how to visualize qualitative and quantitative data. And let's just review a little bit the theory, and then later let's do some applied real-world problem sets too. But let's just begin with a couple of simple multiple choice questions, and ideally you have done them before you watch that video. So one, quantitative data can be measured in US dollars, degree Fahrenheit, distance, and the correct answer is all of the above. Which of the following is closest to a qualitative variable? Height in centimeters? No. Length in inches? No. Volume in cubic meters? No. But mood in smileys, yeah, that would be a qualitative. That's a category. Which of the following is a nominal variable? Height in centimeters, temperature in degrees Celsius, eye colors, and yeah, so basically eye and ear color, they are both categorical variable, but the eye color doesn't have a rank ordering to it. And that's why the next question, which is an ordinal variable, well, that is then year in college, because there's a rank order like freshman, sophomore, junior, senior. Which of the following is an interval variable? Height in centimeters? No. Temperatures in degrees Celsius? Yeah, that's the mother of all interval variables that you can find in textbooks. In eye color, year in college, those were again categorical or qualitative variables. Okay, number 6, which of the following is a ratio scale variable? Height in centimeters? That's definitely true. Temperatures is interval, eye color, year in college, they are qualitative, so the correct answer is height in centimeters. The difference between ratio scale and interval data is that, as opposed to the ratio scale variable, an interval variable has no meaningful zero. And again, when you look at temperature, 0 degrees Celsius or Fahrenheit doesn't mean the absence of temperature. The difference between quantitative and qualitative variables might be best described as follows. Qualitative characteristics are typically blank, quantitative characteristics are. So qualitative characteristics are typically counted, and quantitative characteristics are typically measured. So for example, you measure the height, you measure the temperature, but you count how many smileys were there, or how many people have blue eyes or brown eyes or green eyes. So qualitative characteristics are typically measured, qualitative characteristics are typically counted, and quantitative characteristics are measured. Which of the following is a tabular description of qualitative data? Frequency table, yeah, I can do that. A cumulative frequency table, I can do that. I can do crosstabs, so it's all of the above. Which of the following is a graphical description of qualitative data? Pie chart, yeah. Column chart, yeah. Pareto chart, all of the above. In a cumulative percentage frequency table, the last category always has, of course, it's always 100%. A Pareto chart requires the display of the categories from left to right randomly, from highest to lowest frequency, yeah, that's correct. From lowest to highest, no. Such that the highest frequency is somewhere in the middle, no, it's from highest to lowest frequency. Which statement is true? A histogram is somewhat like a column chart. Yeah, this is true. Used to describe quantitative data. Well, that's also true. Has, as opposed to a column chart to describe qualitative data, no spaces between the columns. That's also true. So it's all of the above. You want to compare graphically two quantitative variables for different categories, like, for example, weekly hours spent on studying for a random sample of graduates and undergraduates. What would be a good graphical visualization of the differences? So we have two quantitative variables, hours spent. So a back-to-back stem and leaf plot, that seems good. And in a cross tab, yeah, I can compare mostly to qualitative variables. And a pie chart, it's obviously only for one. So you can combine two in a pie chart. Okay, 15. Using the 2 raised to the k greater than n rule, how many classes would you need to represent the data in a histogram if you have 255 observations? Okay, so now we have to go like this. 2, 4, 8, 16, 32, 64, 128, 256. So we would have to have 8 classes because 2 raised to the 8 is 256, and that is the first, which is greater than 255. So the correct answer is A. A distribution that has a long right tail is said to be, so if a distribution has a long right tail, it is said to be skewed to the right or positively skewed. A distribution that looks relatively flat, so the middle part is not really distinct, that is what we call plateaukurtic. Meso would be normal and leptokurtic would be very flat. An appropriate graphical visualization for the relationship between two quantitative variables could be a back-to-back stem and leaf plot, could also be actually, well, it is actually a scatter plot, because the back-to-back stem and leaf plot, while it is used to compare two data, it doesn't show the relationship. So the correct answer has to be scatter plot. Okay, so now we have a couple of exercises where we need to fill out a table. So a bicycle company surveyed 10 customers, female and male, about their satisfaction with a new e-bike. Satisfaction levels were rated as high, medium, or low. Please complete the tables below based on the survey data. Okay, so let's do that manually. So how many females do we have in total? So we have 1, 2, 3, 4 males. So we have 4 males, and we have 1, 2, 3, 4, 5, 6 females. So that means we have a total of 10. How many females did have a low satisfaction rating or gave a low satisfaction rating? Okay, so we have to go through female, medium, female, low, so that's 1, female, high, female, low, that's 2, female, low, that's 3. Okay, then how many females did give a medium rating? Female, female, medium, 1. So that's 1. How many females gave a high rating? 1, female, high, test person 5, and so that's 1. So I probably made a mistake with the medium because they need to sum up to 6. So let's check again. Female medium, test person 3, female medium 1, and per test person 8. So here I made a mistake, so that's a 2, correct. So now let's turn to the male, and like we can do it manually again, but what we can also do is we can just count the lows. How many lows do we have? 1, 2, 3. So they all must come from the females. So that means there's not a single one male that has given a rating of low. We can double check male high, male medium, male high. So males really like that product. So how many males gave a medium? MH. So we have to look for MM. So there's 1. And how many, so now we can double check how many mediums do we have to have in total. So 1, 2, 3, and that's correct. So just from looking at this table, we now know, because the total ratings must be equal to 10, there must be a total of 4 high ratings, and 3 of them were given by the male. Let's double check. M, male, high. So test person 1 is a male and high, test person 2 is a male and high, and test person 9. Okay. So what we just did, this kind of thinking, that's a little bit related to what we will talk later about, to the degrees of freedom. You know, when you fill out the table, sometimes you can already tell what something needs to be, even if you don't know, even if you omit the manual counting. Okay, so now we can look at the percentages. So among the female, how many found it low? That's 3 out of 6, so that's 50%. Then how many found it medium? 2 over 6, so that's 33.3% roughly. And 1 of 6, that is 60.7%. And of course that will sum up to 100%. What about the males? Well, 0%, 0 of 4, that's 0%. Then 1 out of 4, that's 25%. And 3 out of 4, well, that's 75%. Okay, so now we can see from looking at this crosstab that, you know, obviously the males like that e-bike much more than the women. So that would be one insight that could be inferred from this. Okay, so in the next one we have to do a create a histogram, and yeah, let's see how that works. Okay, so we have, how many observations do we have? That's the first thing we need to find. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 observations. So I can maybe collect this information here and say n equals 16. Okay, n equals 16. So how many classes do we then need? So the number of classes, we have to use the 2 raised to the k greater than n rule. So we would go 2, 4, 8, 16. But it's not greater yet. So because 2, 4, 8, 16, it needs to be one more, so we need to have 5 classes. Okay, so we have k equals 5. So we have again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, so only 2 raised to the 5 is more. Okay, so next we need to determine the class range, and because we have so we use the formula insert equation. So the formula is the number of k, or the class width, is equal to class width equals equation, now we have to do a fraction, and the formula was max minus min, max minus min over k, and then if we plug in the values, the maximum is 20, 0, so that's 20 over 5, so that's 4. Okay, so now let's do that here. So we have already sum 1, that will be the first class that goes from 0, not 10, 0 to less than 4. Okay, then the next one starts with 4 and goes till 8. The next one starts at 8 and goes till 12. And the next one goes from 12 to 16. And the final one goes from, let me just copy this one here. Yeah, so this one is simply okay, so like this, it is correct. Okay, so that would be xi is greater or equal to 16. So let's insert that correct symbol, which is greater than or equal to 16. You see, those categories obviously need to be mutually exclusive, and so the first category goes till 4. I mean, theoretically you could also include the 4, but then here the sign would then have to be greater than, so they are always mutually exclusive. Okay, so the class width is always 4. So now, how many observations do we have that are between 0 and 4? 0, 1, 2, 3. So there are 4 observations that fall into that range. And so there are 4. Okay, 1, 2, 3, 4. Then between 4 and 8, 1, 2, 3, 4. That's another 4. And then how many are between 8 and 12? 1, 2, 3, 4. It's always 4. So 1, 2, 3, 4. It's another 4. How many are between 12 and 16? So 13, 15. It's only 2. 2. Okay. Yeah, I don't know why that doesn't match here. Okay, so here between 12 and 16, maybe I just get my tablet quickly. And then I can write it by hand. So this one, 12 and 16, we said 13 and 15, so that was 2. And the final one, greater than 16, that's another 2. Okay, so now we have our fourth range would actually go from 0 to 4. So we can call that 0 to 4. Then roughly 4 to 8, 8 till 12, 12 to 16, and then I should have here another one. Which is from 16 to 20. Okay, now let's give it a different color. Draw, maybe, I don't know, maybe red. Okay, so now we have, well, let's make it too big. Okay, so the first column is 4. Second column is 4. Third column is 4. And then we have 2 and 2. And this one. Okay, so this would be a histogram. And so yeah, that is probably something that one would call pretty close to being uniformly, almost uniformly distributed, because there's so many that have the same. But anyhow, so we can't really go much deeper into this, but the idea of this exercise was just to review again and practice how to create a histogram. Okay, let's just stop here, and then I think in the next we have again an Excel exercise, but I do that in a separate video.